We will perform a wet dress rehearsal where we will load the spacecraft full of propellant. So one of the modifications we made to the pad to support the Intuitive Machines launch was to load methane and liquid oxygen onto the spacecraft prior to launch. We typically load RP1 and LOX on the Falcon vehicle before liftoff, and we built in the systems at 39A to support loading methane and liquid oxygen. So we'll be performing essentially taking tests or a wet dress rehearsal for that spacecraft on February 7th, and we're tracking well to a February 14th launch.
All right, thank you very much, Juliana. And we have another question on the line. Stephen Clark is there. Go ahead, Stephen.
Hey, thanks, Daryl. I think a couple of related questions, probably for Tim Dunn. First of all, I know SpaceX is talking about certifying Falcon 9 boosters for perhaps up to 40 flights now. From LSP's perspective, what limit have you currently certified reflown boosters for LSP NASA missions? And also, is PACE utilizing a reused or previously flown payload fairing? And if so,
Okay. That question, I believe, for Tim.
All right. Yeah, I didn't hear the end of your question there, Stephen, but I got most of it there. So, so for the reused portion of, are we flying a reused fairing? No, we are not. We are under evaluation with SpaceX right now, and I would anticipate that to happen in the next year and a half or two. We'll see how that goes for the fairing. And as you saw the shot of PACE on the pad earlier, you saw the first stage booster did look a little bit of flight-proven worthiness stripes are on it. So this will be the fourth flight of this particular booster. And to answer your question about how many times we are comfortable with a reflight, Stephen, it's more, we don't look at the number of particular flights of a booster. We look at the qualification status of all the components that go into that booster. And so we do an evaluation, and as long as we do not exceed qual status, and some components do get replaced in between flights, and then we do the analysis on some of the structures that are not replaced, we are comfortable. So far, I think we have flown, I know we've flown a fifth booster, and did we fly a sixth booster?
Europa Clipper will be a sixth.
Europa Clipper later this year will be a sixth flight currently. So you can see we're comfortable through analysis of components in that 4 to 6 reflight time frame today, and we continue to work alongside SpaceX to see if that number will go up in the future.
All right, thank you very much, Tim. And we want to circle back to a question in the room. Bill?
Hey, thanks. For Jim Free, can you talk about if the IM-1 flight goes off on the 14th, where does Crew 8 go? And if the fueling test doesn't go well on the 7th and you can't make the February window for IM, where would Crew 8 go in that case? Can you give us those two options, please?
Yeah, sure. So we're obviously following closely what's happening with IM for a lot of reasons, right? That's our CLIPS, one of our CLIPS missions, so it's important to us for the science we're going to get there. Right now, we're the 22nd is what the team is working to. If we have to watch what happens there, it could push out later to the end of the month, Crew 8, I mean. To later in the month, but right now we're working towards the 22nd with the possibility of going later depending what happens with IM.
Just a real quick follow-up for Juliana. Can you give us the launch window for IM in March? And how many days do you have in February to get off?
There are 3 opportunities, the 14th, the 15th, and the 16th, and I actually do not know the liftoff time, so I'll have to follow up with you offline with that. Oh, in March. I don't know the answer to that question.
All right, very good. Now it's time for some hashtag Ask NASA questions, so buckle up, everyone. Here they come. We're going to start with a question from Maxinator 2002, and he asks, why isn't this Earth science mission launching from Vandenberg, California? Because that is where most polar orbiting satellites launch. This is a very informed question. observing that we do most of our science missions out there. So Tim, why don't you take that?
Right. I'll start this one, and then I'm going to turn this over to Juliana. But the way that the Launch Services Program contract with all of our launch providers is constructed is that all of the providers will bid on the opportunity to launch any of our spacecraft. And as part of that, we give the freedom to each of the providers to tell us what the best solution is for that particular spacecraft. So historically, this would have launched out of Vandenberg into a typical polar trajectory off of the central coast there. But SpaceX chose to bid the opportunity to fly here from the East Coast because they have the capability now. So, Juliana, you want to take it from there?
Yeah, sure. We wanted to optimize for Tim's commute. One of the things, when we're proposing a mission, one of the things we like to look at is to make sure we account for what the spacecraft team prefers. And in this case, the spacecraft team being from Goddard, they preferred to launch closer to their center. So Florida is much closer to Goddard than California, and so here we are.
All right, thank you both very much. Next question from #AskNASA comes from B, watching on YouTube. Would like an explanation of the blob images on the backdrop behind you. So if we go to a wide shot of our lovely graphic that we have behind our panelists, you'll see that lovely shot there. And I'm assuming the blobs are to our stage left at the far end. So Karen, direct your attention to that. Do you know what B is referring to?
I do. In fact, this is an image taken from our Landsat satellite. That's a partner mission with USGS, and it is intended to, in a very small way, represent what we will see from PACE. This image is actually off the coast of Brisbane, and you're seeing a number of features there. Off to the left, you'll see coral reefs. Over land, you can see smoke from wildfires. We can see some algae growing near the land. We can see some clouds. And even algae in the inland waters. So this is indicative of all the kinds of things we'll see from PACE, but PACE will give us another dimension to this, the beautiful imagery we have behind us. And I appreciate the question because it gives me a chance to say something. When we're talking about science, we don't always say this, but the imagery that we get from our satellites shows us in a new way how beautiful our home planet is and what a gem it is in the universe. So yeah, that's what this is.
Excellent. Karen with a sharp eye for the Landsat image, identifying that. That's well done. All right, moving on with more #AskNASA questions. We have Carol Kravitz asking, will PACE help with the analysis of heavy metals like mercury in fish populations? Karen.
It's a great question, and I don't know that we'll be able to measure mercury directly, but what we will be able to do is measure attributes of the community of phytoplankton that the fish eat. So we will be able to see changes in the fish food, and that will tell us an awful lot about fish health.
All right, very good. Another question. Chris Isles asks, will PACE help identify which nations contribute most to ocean acidification? And more importantly, how do they do that?
Well, so PACE is a global mission. We'll see all of the Earth's oceans, and through the ocean color measurements, we'll see what's growing where. Now, there are a lot of reasons that phytoplankton grow or don't. They need three things. They need sunlight, they need carbon dioxide in the atmosphere, and they need nutrients from land. They need nutrients to grow that they extract from the water around them. So how do the nutrients get there? One way is that the nutrients get transported from land via rivers and things like that. Another way is upwelling nutrients from the deep oceans. And a third way is actually from aerosols. All of these are global processes, but they play out differently locally, regionally around the world. So we'll learn a lot about the differences that we see around the coastlines and the deep oceans around the world. Yeah.
And you touched on this in your earlier comments, but the interplay between PACE and SWOT. PACE looking at the biology, SWOT looking at the movement of the ocean. Is there any impact that that would help us shed light on the question, the acidification of the oceans?
Yeah, so generally the acidification of the oceans occurs through precipitation from the atmosphere, right? That's really the source in many cases. So with PACE, being able to observe the aerosols in the atmosphere and tell us about the biology, and SWOT telling us how water is moving around the planet, both that upwelling of deep ocean water, but also the movement of surface water. Yeah, these two systems together will really shed new insight into the ocean's health and how that's changing.
All right. All the questions are pointing to science at this point, Karen, so we appreciate you, fielding all of these.
We can talk all day about it.
Oh, excellent. Very good. Well, we only have about 20 more minutes, but we'll certainly use what we have. High Q asks, NASA has studied Earth's atmosphere in the past. What is it you hope to learn that you don't already know?
That's a great question, and I'm going to pivot away from the ocean observing part of PACE for a moment and talk about the two other instruments on the satellite that really characterize aerosols in the atmosphere. These aerosols play a really important role both in short-term weather. They seed clouds, which can grow into storms and hurricanes. They also play a role in climate and the stability of climate. Aerosols reflect the sun's light, and they determine exactly what the composition of the aerosols is, how big they are, what their shape is, and where they are in the atmosphere will determine what kind of clouds they seed. That relationship between aerosols and clouds and its relationship to near-term weather and long-term climate is the greatest source of uncertainty we have, in particular in climate modeling. So this new insight from PACE will help us address the role of aerosols, how they create clouds, and how that plays out in terms of the forcing in climate feedback. Really important stuff. And then, of course, there's a relationship between the phytoplankton and the aerosols. I mentioned nutrients that we need for phytoplankton. Often that can come from aerosols. We had a case with the wildfires. Remember the wildfires in Australia? That was a case where tremendous amount of burning led to carbon dioxide, but also aerosols, smoke in the atmosphere. That smoke carried nutrients out into a part of the ocean that normally doesn't have them. That drove an algae bloom, which then actually took carbon dioxide out of the atmosphere. So this interplay between the atmosphere and the oceans is critically important for us to understand how the whole system's changing.
And I'm glad you mentioned the wildfires in Australia. We have great imagery of that showing how that worked, and you can see that on tonight's launch broadcast. So shameless plug for the launch broadcast. Tune in, 12:45 p.m. In fact, I think I'm just hearing from our producer that we have that imagery.
Okay.
So we're taking it right now. And Karen, talk us through, as you look to Australia to the far left, you'll see it start to flare up.
Right. So what you're looking at here is actually the output of a model that takes all of the data we do have today and fills in the gaps with a physically driven model. So what you're seeing here are different kinds of aerosols. The colors on the bottom represent different kinds of aerosols. The intensity is how much. When we have a wildfire burning, such as you see in this loop in Australia, you'll see the orange aerosols, the carbon aerosols light up. Those also carry these other nutrients like iron and so forth that then get carried out over the oceans. I love this graphic because it shows how connected the Earth is as a system. But as I said, this is a model. What PACE is going to do is give us this kind of imagery, except from data. So it'll fill in all the gaps we currently have.
All the way around the world, too.
All the way
that
around the
plume.
world, yep.
Impressive. Thank you, Karen, for speaking to that on the spot. Appreciate that. Another question now. Moving from science to the spacecraft. MLG Pure asks, what is PACE's expected lifespan?
Oh, yep, I can answer that one. So the design life for PACE is 3 years. That said, usually our satellites live a lot longer than their design life, and that's why we're carrying 10 years worth of what we refer to as consumables. That's the fuel we use on board for station keeping, and when it reaches the end of life, to make sure that the disposal is safe. So we expect PACE to be on orbit for, we hope, 10 years, maybe even more.
Scientists are always hoping for more.
We are optimists.
All right, very good. We have a question now coming in on the phone line. Richard Trudeau from the Orlando Sentinel. Go ahead with your question.
Hi, yes, thank you for taking my question. This is for Karen. How much of this satellite data will help feed hurricane-related mitigation efforts? And what is the, if it's considered part of the arsenal of hurricane-related satellites that NASA is running up? That's it. Thank you.
Absolutely. That's a great question. One of the things I briefly mentioned at the beginning is that dust blowing off the Sahara is a big catalyst for the storms that develop over the Atlantic. And when the conditions are right, those storms can gather and strengthen and become tropical storms and hurricanes. So we expect the data coming from PACE to be a very important improvement in our understanding of how that process happens, and improving the predictive models that predict hurricane intensification and track. So I should mention here, most of what we do through partnerships, and NOAA is a principal partner in this mission. They are an early adopter for many reasons, ranging from weather prediction to long-range climate to the harmful algal blooms and the things that affect fisheries. So yes, absolutely, this will be an important new piece of information that will support hurricane prediction.
All right, staying on the phones now, another question from Will Robinson-Smith. Go ahead, Will.
Yeah, thanks for taking another question. This one also going to Karen, and then a quick one for Brian, if I may. I know the data from PACE will be made available to the public sort of continuously, but does NASA have plans for an annual report system from PACE, and what might that format look like? And then question for Brian, in the launch weather forecast for overnight tonight, is there any probability of hail in the forecast from a launch weather perspective? Thanks.
All right, I'll start with PACE. Yeah, absolutely. PACE is one of our, all NASA missions, all NASA Earth science missions and science missions in general abide by open source science principles. And here's what that means. That means we not only make all of the data freely and openly available, but we put the data, the algorithms, the models, we put all of that information out in real time. That does a couple of things. One, it accelerates the rate of scientific discovery if we have more eyes on the data and the tools in the hands of the science community. But it also accelerates the use of the information from missions like PACE by agencies and communities that can really make use of that information. In terms of a report, we have not historically focused on annual reports so much as continuous release of data and information. We have, if you go to earth.gov, you can see all of our Earth science data and learn more about the stories that we can tell with that data. And starting about 60 days after launch, you'll start to see PACE data showing up there as well.
And you can learn a lot more of that tonight when you watch the launch broadcast. I mistakenly said 12:45 p.m. I want to correct that. It's 12:45 a.m., as we all know. And we'll be setting our clocks to come in early tonight.
And
all right. Brian, yes, I want to
Yes.
get the weather part of the question.
So I mentioned that upper level low during my part of the briefing there, and essentially part of that is it's very, very cold in the upper levels of the atmosphere. So that's part of the reason why we saw some hail reports yesterday. Today it doesn't look quite as favorable to get hail as yesterday. We don't have the amount of instability that we saw yesterday, so that's a necessary ingredient to get hail. Having that said, because it's so cold in the upper parts of the atmosphere, there is a small risk for small hail today, but lower compared to yesterday. I think it'd be more so earlier in the day today compared to the launch window, but it is a small risk given how cold it is in the upper levels of the atmosphere.
All right, thank you, Brian. Another question from #AskNASA. Con Savvy on YouTube asks, what are some of the awesome tools, the instruments on PACE? She believes they're awesome, and they are.
Well, we have three principal instruments on PACE. One is the ocean color instrument. That's the one that will produce the imagery like what you see behind me. And then we have two instruments called polarimeters. These are the ones that are measuring all those attributes, the shape, the size, the makeup of the aerosols in the atmosphere. So those are the instruments we have on board.
All right, and another one from #AskNASA. On YouTube, Freya Wild will ask, will PACE tell us about the oxygen created by phytoplankton? I'm guessing yes.
Yeah, it's a great question. So just like plants on land, phytoplankton grow using photosynthesis and oxygen and nutrients. And a byproduct of that process, just like plants on land, is oxygen. So knowing more about the abundance of phytoplankton, there are 20,000 species or so, and a billion phytoplankton in our oceans. So learning more about the abundance, where they are, what kind they are, will certainly tell us about what they are consuming and what they are producing. And in this case, what they produce is very helpful to us. It's the air we breathe, it's the oxygen in the air we breathe.
Indeed. All right, well, great job, everyone. Thank you to all of our panelists for answering the questions. Special thanks to Karen St. Germain for answering a ton of questions today. Very good job with the science. We really appreciate it. Yeah. So if you'd like to learn more about PACE, just go to our website at nasa.gov/PACE. Again, nasa.gov/PACE. You can learn a lot more about the mission that is happening once that satellite gets up into space and commissioned. And as I've reminded a few times, the launch is at 1:33 and 32 seconds a.m. Eastern Time tonight, and our coverage for NASA television begins overnight at 12:45 a.m. Eastern Time. Thanks again to all of our panelists, and for all of us, for all of you joining us in the room and on the line, and at #AskNASA. I'm Daryl Nail. Thank you, and go PACE.